like Kirchhoff. Ah, you do. You love Kirchhoff. He's your favourite. He's my favourite. Okay, open. Okay, so if you can write his name down first. Kirchhoff. I think I spelled his name wrong. I think there's two O's.
Isn't it Kirchhoff?
Or two F's. Or two is something else. Two F's, isn't it?
Two F's?
I think there's two F's. Kirchhoff.
Yeah, I believe it.
Just check.
I'll tell you right now. Yes. Two F's.
Two H's as well.
And two H's. And two H's and two F's.
Look at his name.
Kirchhoff. Yep. Okay. So, Kirchhoff's laws. Right. Come on, Grace. It's not so bad. So, Kirchhoff's first law, he has two laws. So, Kirchhoff's first law is called the Junction Law. And it says, at any junction in a circuit, the current that flows into the junction is equal to the total current that flows out of the junction. Or as a formula, the total current at the junction must be zero. Now I'll explain what this means with a picture in a minute, but you'll need to write his law down. Do you know this word in English? I'm sure you two know junction. Amanda and Grace, do you know this word, junction? Okay. You know you have two roads, and the roads meet? We call this the junction, where the two roads meet. There's other names for it. Do you guys know other names for junction? Yeah, that's called junction. Another word for junction on roads. So if you have roads that meet like this, we call this a junction.
Roundabouts or something.
Nah, not roundabouts, something else.
Small.
Like a T, yeah. Crossroads. Yeah. Anyways, that's junction. Do you have this? Junction.
10 and not 10. Plus or T.
Yeah, they're both called junctions. So you have T junction and junction.
So junction is plus?
It's both. This is junction and this is also junction. It's just a T junction, yeah. Okay, so let's explain what Kirchhoff means. So what do you mean, Kirchhoff? Well, what? Yeah, Kirchhoff, our friend. So what Kirchhoff said is the current that goes in here, we'll call it I1 and I2, equals the current that comes out. So as a formula, that's like Kirchhoff says, I1 plus I2 minus I3 should equal 0. Or, the way Kirchhoff says it, the total current at the junction should equal 0. And just be careful, the plus means in and the minus means out. Why? Well, the reason is because charge is conserved. Now, do you know this word? Do you remember this word? Where did we see this word before? Conservation of energy. So, in fact, charge is conserved. That means the charge doesn't change. The charge at the start equals the charge at the end. It's conserved. So this is Kirchhoffs Junction Rule. Okie doke? Yeah? Alright. Oh, sorry, Amanda, do you need to write this?
No.
You got it? Okay. So, like I promised, Kirchhoff has two rules. So, the second rule is called the loop rule. I just drew that already for you. So, the second one, Kirchhoff's second law, the loop law. The sum of the voltage around a circuit is zero. The total voltage on a loop is zero.
What does this mean? That's directed, so.
Oh, that's just a fancy way of saying add them up.
Active listening is on Tuesday.
I'm doing it. Last time you did it with chemistry.
What does that mean? What's active listening?
It's listening you do actively.
What does that mean?
You should know. Your EAP teacher is talking to you about it, no?
No.
What do you mean no? What have you been doing in EAP class with Dennis? Remember, I saw you there yesterday.
We've just been.
So this is what happens. I deliver a special 20-minute lecture.
Oh, is it not from the radio anymore?
Huh?
The last time we did it on spec from the radio.
From the radio?
Yeah,
Or maybe that was a
yeah.
practice one, I don't know.
It was practice.
Yeah, it was just practice, yeah.
Because I was thinking to go
Got
to
this?
the,
Okay, so let me explain what this means. So do you remember, for example, here is a resistor, here is a resistor, and then here is a cell. And for example, this one is E, and this one's voltage is V1, and this one's voltage is V2. What do you know about V1, V2, and E?
Must be not equal V1 plus V2
V1 plus V2 equals E. So this is what Kirchhoff says, V1 plus V2 equals E. But he doesn't write it like this. Instead, it's like this.
V1 plus V2 minus V equals 0.
The other way, E minus V1 minus V2 equals 0. So look, this provides voltage, and then what do the resistors do? They use or consume voltage. So as a formula, it's like this: total voltage equals 0 when you travel around in a loop. So this is called a loop.
So the second law is just used in the voltage.
Yeah.
So the first law is used to the current.
Yes. And this is because, do you remember what voltage, the unit volt means? Do you remember what volt is? A volt is one watt. Does anyone remember?
The potential difference.
Now, 1 volt is...
1 joule per second.
No. That's
1 ampere divided 1.
No. 1 volt is 1 joule per coulomb. So this is the reason the voltage must equal 0 is because energy is conserved. It's not so bad, is it? The first time I taught this course, I didn't like Kirchhoff. But now I really like Kirchhoff. You should like him too, okay?
Why? What did he do?
He's great. This is all great stuff, okay? Continue.
The exam ask what is second law?
Yeah.
Can I repeat it?
In the exam, if they ask you what the second law is, they usually let you write it in words or a picture with this. Yeah.
Okay. What the first law?
Yeah, same.
Okay.
Yeah. Okay, let me draw this. I did. Right, now let me give you some advice. Now you don't need to write this down, or some of it you can write down. So some advice, some tips. Don't forget, you can still use these formulas we've done, V equals IR. In fact, V equals IR is very important, and we usually use it with the loop rule, because it's voltage. Generally, we usually use the junction rule once. Not always, but for most of our problems, we usually use the junction rule only once. Often we need to use the loop rule more than once, like twice. If the loop goes the wrong way through a battery or a resistor, then the voltage increases. So I'll just draw with that what I mean by that. So for example, here's my loop. I start here and I loop around like this. So here is my battery, and then here is my resistor, and then we go around like this. So this one here would be a plus E, and this one here would be a minus V. But if I go around my loop this way, then this would be a plus V if I'm going backwards, the wrong way, and then this one here, I'm going the wrong way, this would be a minus E. So just be careful about that. If you make your loop backwards, then the plus becomes minus and the minus becomes plus. Okay? So my advice is don't go backwards. Try and go with the battery. It makes it easier for you. You can choose any loop. However, it's easier to use a loop with a cell in it and to go with the flow. So start with the cell and go in the direction of the current. So we definitely need to do an example of using Kirchhoffs rules. Now you don't need to write all this down, this is just little tips. If you found something here really interesting that you didn't know, maybe you should make a small note of it. I think for me the most important one for me is I always like to start with a cell and go in the direction of the flow. Go with the flow. Okay. Go with the flow. You know this? Go with the flow? You don't know go with the flow? So if the current goes this way, you should also go this way. Go with the flow. Yeah. Please don't write all of this. This is just my little tips, okay? But if something was useful, write it down. Can I continue? Yeah. Now, we have done this one already, but this time I'm going to do it again, but using Kirchhoff, and we should get the same answers. So firstly, please draw this. Yeah, draw this. Yeah? You draw this? Okay, can I draw it? Okay.
No. Perfection takes time.
Sure does, sure does.
Okay, now I'm done.
I would settle for nearly perfect though. Okay, what was the resistor on the top?
1,
So it goes 1 and then
2,
2,
3,
3, 4, and then the battery here was this way, 5. Now, remember the last time we did this, we had to break it up, make it parallel and then and so on and so on. It was long. But with Kirchhoff you can do it quicker. So
Wait,
firstly, yeah,
5 volts or 5 volts?
5 volts in the middle, the cell.
But a cell has resistors, right?
Ah yeah, but we'll get to that later. So here we have a current. Let me call it I1. Then what happens here to the current? It splits. This way is I2, and this way is I3. This one, oh sorry, I didn't draw my resistor in here. This one here is still I2. This one here is still I3. This one here is still I3. And then they come back together, and what will it be here? I1. Okay. Here we'll have a voltage. Oh, well, we won't draw that. Okay. Shall we start the Kirchhoff? So first, let's use Kirchhoff's junction rule right here. So Grace, what current is going into the junction? In. You're not Grace. Yeah. I1. And Grace, what is coming out? Yeah, so what's next in my formula? Plus or minus? Yes. So minus. These are going out. This is going in. Use Kirchhoff's junction rule here. So in is I1 and out is I2, I3. So I1 minus I2 minus I3 equals 0. Yes.
In the end of the electric.
Here, this is I1. Yeah.
So they change.
Yeah, so they come back together here. This must be I1 because it's I1 after the battery, after the cell. Okay.
I1 goes out, goes in.
I1 is here, yeah, in the middle. And then here, this is I3 and I2. I2 and I3.
Together.
And then, yeah, back here they add together and go back to I1. Yeah.
And equals 0.
Equals 0. Yeah. Okay, Sohi, let's use the loop rule. So, which loop do you want to make? You can make a loop on the top, or a loop on the bottom, or a loop around the outside. Oh, I was hoping you wouldn't say that. A loop around the outside is fine, but I like to use the cell if I can. So I'm going to use, you can use the outside if you want, I'm going to use the cell here. So I'll start here. What's the voltage of this cell? 5. So we start off with 5. Then I go along here and I go up. What's the voltage here? We don't know, but if I use this formula, we can know it. What's the I here? I3. And what's the OR? 2. So this will be minus 2 I3. And then when I get here, what happens?
1 I.
Minus 1 I3. And then back here is equal to 0. Okay, and let's use the loop down the bottom now. So again, I start here, I have 5, but then I go this way. So what happens here? Minus 3i2, and then when I get here, minus 4i2 equal 0. Right. What can you get from this equation here? I3. What can you get from this equation? I2. Therefore, what will this give you? I1. Okay, so I2 will equal 1.67 amps. No, sorry, that's I3. I2 will equal 0.71 amps, and so I1 equals 2.38 amps. Can you check the answers that when I did this last time in the simple circuits? Did I get the same answers? Do you have the simple circuits? There, this is simple circuits.
Yeah.
1.6, 0.7, 2.38. I got the same answers.
This is so much easier.
This is why I like Kirchhoff, because this is so much easier.
Without knowing the...
Now, could I get the voltages? Yeah, how do I get the voltages? I just use this formula. So the voltage here will be I3 multiply 1. So let's finish by getting the voltages. So we'll call this 1. V1 will equal I3 times 1. So what's that? That's 1.67 volts. V2 will equal I3 multiplied by 2. So that's 1.67 multiplied by 2. So that's 3.34 volts. V3 will equal 3 multiply I2. .13 volts, and then V4, that's this one here, I2 multiplied by 4.
The total voltage is 5 volt.
Correct.
Yeah.
So this should equal 5, and this should equal 5, because it's in parallel. Wasn't that so much easier than when we did it with the simple circuit diagrams?
Why is there V4?
There's
Oh,
4
yeah.
resistors. Please note, if you got, look please everybody, if you got a minus here, that is okay. For example, if this was minus 1.67, that is okay. What that means is on your diagram, you drew the current going the wrong way.
Yeah.
So minus here is okay. And minus here could be okay as well.
We can just change the minus to positive.
No. If there's a minus, that means the picture is the wrong way, and that does happen in the exam. There's nothing wrong with it. And don't forget about the batteries. For example, if this one here was 10 volt cell, and this one here is the wrong way, it was 3 volts, then what happens when I put them together? I only get 7 volts. So if I go this way, I get 7 volts. But if I'm going this way, it's actually minus 7 volts. So just be careful with the plus and the minus. It is difficult, I know. Continue? Yeah. Right, so what I would like you to do, there is plenty of time. What I would like you to do for me now is draw this circuit, and then the first thing is to make the equation. So the first one, right? Junction rule at B. Can you see where B is? Here. Junction rule. And then junction rule at E. Yeah, so anyways, I want you to try this for me, okay? And if there's time, we'll do it together. But can you draw this and then try to make the equations?
Zoom the circuit a bit.
I can't actually because it's PDF. This is as good as it's going to get. Now look, do you see here? This is 6 and this one we don't know. This one here is 12 and this one we don't know. This one is, oh, wait, sorry, no, that's wrong. Sorry, I don't know what I'm saying. The only things we don't know are I1, I2 and I3. What I was saying here in my terrible picture is this E2 is 6 volts. I know it looks like they're different, sorry. I should delete this maybe. And this E1 here is 12 volts. So this is 12, this is 6, this is 4, this is 4, this is 16. This current is I1, this current is I2, and the one in the middle here is I3. I need to fix that picture, so okay, so have you drawn it? Yeah, okay. Right, try this one now. Hang on, I want to just open up the picture. What's that? You need to make the questions, is it? The first one is the junction rule at B, and then the junction rule at E. And then the next one is what have you noticed about these two equations? So make a junction at B and a junction at E for the first two. Right, I want to delete something. Where you go? Okay. Okay. Yeah. That's better. Much better. Okay, Amanda, have you made the junction at B? Are you writing down all the questions? No. What are you doing? No, I don't. It's okay, you don't need to write them all down. I want everybody to tell me the junction rule at B. What's that?
B
Yeah, B.
is I1
Yes?
minus I3
Yes?
B.
B, up the top here.
Oh, okay.
Grace, you give me the junction rule at B.
I3.
Wait, I'll get you next. Give me the junction rule at B.
Because we have
16?
16 I1
No, not at the junction. Just the I1, I2, I3.
I3
Here, this is I1 going this way.
yeah.
This is I2 going this way. And going down here is I3.
I go right. I know.
Do you know?
I
Hang on. Give her a chance. Yes? I don't want the loop. I want the junction. What goes in, what goes out. So what goes in at B? And? Yes, and what goes out? Yeah, so give me the equation. Go on. Yes? Yeah? Okay. Listen. I1 plus I2 minus I3 equals 0. Because I1, I2 go in, I3 comes out. Yes?
It's at E.
At B?
B, yeah.
Yeah. Okay.
No, isn't it I1 coming from this side?
I1 is going into the junction. I2 is going into the junction, and I3 is coming out of the junction.
So the question is I1?
I1 plus I2 minus I3 equals 0. No, you don't. You like them. Really? Really? Okay. Sohi, can you give me the junction rule at E? Good. So can you write that down, everybody, for the next one? I3 minus I1 minus I2 equals 0.
It's 3 coming this way?
Yeah, 3 is going in, and 1 and 2 are coming out. Now, did you write those two down, Hareen? So, Hareen, you give me this part C. What have you noticed about these two equations?
They're both equal to 0.
And?
And they're both the same, it's just arranged differently.
Yeah, they're both the same, aren't they? So do we need to use both of them? No, so we can cancel one of them. Okay, Amanda, do you feel you can make the ABEF loop? ABEF, the left, on the left, the loop. Okay, so everybody listen and write down Amanda's equation. Okay, go Amanda. 12
minus I1 multiplied 4.
Yeah, 12 minus 4I1.
And minus 16.
Yes.
I3
Minus 16I3.
equals 0.
Correct. Did you write that down?
No.
12 minus 4I1 minus 16I3 equals 0. Grace, make the loop on the right. You can do this.
After minus 16 I3.
Yeah.
The left.
Yeah, we go. So what Amanda did was, Amanda went from here around, wasn't it?
Yeah.
AB, yeah. So it was 12 minus 4i1 minus 16i3 equals 0. Yeah. Great. Start here. 6.
6 minus 4 I2
Correct. Minus 4i2.
minus 16 I2. Oh, no, I3
Very good. Minus 16i3
equals 0.
equals 0. Good. Write this down.
What did she say again? Wait, let me
She
get
said 6 minus 4i2 minus 16i3 equals 0. Okay. Sohi, I want you to make a loop that goes around the outside. Okay? So where do you want to start?
the cell.
You are not Sohi. Where do you want to start, Sohi? Alright, start at 12. Okay, so 12. Yep.
Minus 4 I1
Yep, 12 minus 4i1.
minus 4 I1
Sorry, not minus. Plus, because the current is going to the left and you're going to the right. It's the wrong way, so you change it. So, just be careful, everybody. 12 minus 4i1 plus 4i2, because it's backwards. You see the current here is going left.
Yeah.
Which way are we going? Right. It's backwards.
So it's plus change when the wrong
When it's the wrong way, it's a plus instead of a minus.
so it's the right way. Well, right way is minus.
Minus, yeah. Yeah. Okay. Right, now, the difficult one. Take your time. What do you think happened here? Why? Yeah, we're going backwards through the battery. We should be going, the battery wants to go this way, but we are going this way.
Yeah.
So we lose 6. So it's minus 6 here. Yeah. Yeah?
It's not plus 6.
Yeah, because the battery goes which way? Up.
Up.
And which way are we going?
Down.
Down. Now the battery normally makes voltage for us. So this should be plus 6, like at the start. But we are going down the wrong way. So it's minus 6. Yeah. And finally, Sophie? Equals 0. Okay. Let me type in the 3 equations. So, what was my first equation? Now, please, instead of I1, I2, I3, we can have x, y, z. So, what was my first equation?
x1 plus x2.
No. X, y, z for I1, I2, I3. So, what's the first equation? No, the very first equation.
Plus y.
X plus y minus z equals 0. Next equation?
The second one is I3.
No, x, y, z.
X.
Z
Minus y.
minus y
Minus
x equals 0.
Wait, isn't the I1 x?
Yeah.
Then it's z minus x minus y equals 0.
Whatever. It's the same thing, really. Okay. Now, the loop. Who did the first loop for me? Was it you, Amanda? Yeah, so what was your equation? You did the loop on the left, didn't you?
Yeah.
Yeah, so give me this equation.
12
12
minus 4I1.
4x.
4x.
Yep.
And minus 16x.
16z
Equals 0.
equals 0. Okay, who gave me the next equation? Was it you? Yeah. 6 minus
4y
4y
minus
minus
16z
16z
equals
equals 0. Okay, and then so you gave me the last one. What was it?
12
Yep.
minus 4x
Yep.
plus 4y
Yep.
minus 6 equals 0.
Okay. Now, x, y, z is I1, I2, I3. How many equations do I have? 5. But how many do I need?
3.
I only need 3. Now, I can't pick any 3. For example, if I pick these two, why is that bad? Because they're the same. So I should delete one of them. So, okay. I'll pick this one. And what other two are nice?
The 12.
I like, if this was in the exam, which one should you pick? 1, 2, 3, 4, 5. Which ones would you pick? 1,
1 through 4.
3, 4. Because what can you do with 3 and 4?
You can 16 is cancelled.
You can cancel the z's.
Yeah.
And then you just have y. And then once you have y, it's easy then.
Can you use I1, I2 a bit more?
1, 2, no you can, but I can't type I1, I2,
Yeah,
I3.
that's
Yeah. I only changed it because of typing. So are we all happy? We should use 1, 3, 4.
Yes.
Okay.
You need to do the 5.
Yeah, which ones? 1,
3 and 5.
3, 1, 3 and 5? I think so. Let's see what happens. If I try to solve 1, 3 and 5, should I get an answer? 1, 3 and 5. I get this. Now let's try a different one. What was the first ones we said?
1,
1,
2, 4.
1, 3 and 4. Should I get the same answer?
Yes.
I hope so. Otherwise there's something very wrong. Please, 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 please. Alright. Yeah, okay. So to answer your question, so you see you get the same answer.
But this
Oh, this just means and. X equals 1 and y equals minus a half and z equals a half. Or x equals 1, y equals minus a half and z equals a half. Now this is interesting. This one's negative. So what does that mean on my picture? It's going the wrong way. So if we look back at the picture, which one's negative? I2, isn't it? So this is not going that way. It's going the other way.
to the right.
Yes, it's going actually to the right. Because the answer was negative.
Should we change it?
No, you don't. You don't.
Keep minus.
Keep the minus. The question, so here's my last question for this. Which way are the electrons moving here? From C to D or D to C? Don't say, just think 1 minute. The electrons, C to D or D to C?
The current is
No, talking. I won't tell you anymore. Just figure it out. Okay, which way?
No, from where to start?
Yeah, the electrons. Do they move from C down to D, or are they going from D to C?
From where the electrons on the earth in?
The electrons here.
Alright, then it doesn't matter.
Doesn't matter.
I choose D to C.
Correct. Because this I2 is minus, yes? So it means the current is going this way. So the current is going down. That means the electrons are going up. So it is D to C. Yeah. Sorry, do you need to draw something here?
The right.
Sorry, yes, Sophie? Yeah. Sorry. this is plus and this is minus, yeah?
Does it mean if current is going down?
Yeah, so because this is minus, it means the current is going down. Now, the current should be going up because the plus is here and the minus is here. So why is it going down? Does anyone know? Why is the current going down? It should be going up because the plus is here and the minus is here. Does anyone know why? Yeah, well, it's because of the I1. Because this battery here is so powerful, it pushes the current the wrong way here. That's what's happening. So this one is dominating this one. Okay. I'm going to just make a small change here. Which way are the electrons flowing? Which way are the electrons flowing at the 6-volt battery? Okay, homework time. So do we like Kirchhoff or not? We think we like Kirchhoff? For now, okay. Alright, so your homework, yes. So in question 1 and 2 you need to draw it, but in 3 and 4 I give you the diagram. Now you might need to watch the video and pause the video because the numbers here are small. But I upload the video every night, so you can watch it tonight. Hello Kitty?
Yes.
No Doraemon?
No.
Doraemon is much better than Hello Kitty.
I know.
Oh, you do? Oh, good.
Yes, I love better.
Oh, good.
But Hello Kitty is pink.
Hello Kitty is pink and Doraemon is blue.
Yes.
Yes. I will get Doraemon for my phone.
Your phone?
Yeah, my phone. Look, my iPhone. See? iPhone 8.
8.
Yeah.
iPhone 10.
iPhone 10. Yeah. Okay. Now, just please check with Connell for next week because there's the active listening and stuff like this. So please check your emails, especially from Connell. I don't want people going to the wrong room at the wrong time, okay?
Okay.
Alright, see you tomorrow? No?
No, that's
See you next week then, okay.